This is the web of data. Actually, it's much bigger than here. But if we look at roughly what kind of data sets you have, you see in yellow there's a whole bunch of publication databases, published scientific papers with the authors, etc., etc. There's a whole bunch of social network analysis sites that are now also available in RDF. Then there's media sites in RDF. Of course, everyone is using the DBpedia, the RDF version of the Wikipedia. And today will be about a demo of linked data in the red cloud. What I'm going to play with is a database of diseases, daily medicine, clinical trials, drugs, and a database of side effects. And then one of the things that happens when you go out in the field and you try to work with all these linked data sets is that initially you have no idea where to start. I mean, you've got a bunch of databases, you know they are somehow connected, but how do you get an insight in what connects to what? So we've written a tool that will take linked data sets, find all the types in there, and then creates a kind of a schema space so that it's a lot easier to figure out how one type of entity or RDF type in one linked data set can be reached through a set of other databases in another database. So basically I created a schema space, and you can connect any two types in your total schema space, and you'll find out how they connected through other data types. So I go to Gruff. Gruff is our visual navigation tool on top of our triple store. It allows you to open triple stores and load triple stores. So, but I was talking about drugs, so just let me find the drug. So if I'm in Gruff and I'm now in the graph view, if I hit the letter J, then I get all the types in the database. Here you see the first letters of most of the types. So let's go to the D, let's go to drug. And there's drug interactions and drugs. Let me get drugs. And now what you see is all the drugs that are in the system, and say I'm interested in amoxicillin. Then I can go here, say I'm interested in the tablets. And so now I have here one item that I can look at. And one way to look at the features, I selected this node in the graph. I hit the letter T. So what you see here is triples. Amoxicillin has an active ingredient, amoxicillin, and active moiety is also amoxicillin, so this is the active ingredient. Then you have the adverse reactions, you have the clinical pharmacology, the contraindications, somewhat of a description, the dosage, the full name, etc., etc., open dosage. And then you also have some things here, same as this, which are interventions. And interventions are kind of the experimental effects from a clinical trial. So I can click on an intervention. And so someone did an experiment where they used 2.5 milliliter of bubblegum flavored amoxicillin. And it was in a clinical trial NCT00106197. So I can click on that one. And here you see the clinical trial, and you see the criteria for when you can be part of this trial. So for this one you have to be depressive and you can't be pregnant. There's a lot of text in the clinical trials, and there's a lot of information, but there's only a few 30, 40 triples. So here you see a description with a lot of text, and here's a small summary. Oh, well, usually it's a lot bigger than this one. If I hit the G button again, I actually can see how I took a trip from amoxicillin through intervention to this particular trial. And if I hit the letter Z, I go back to every previous step that I've done so far. So say I'm interested in zestril, I hit a semicolon, and that brings me into the free text query. Actually, everything I do here, usually I can click on add, and then you can say add triples by free text query, or add subject nodes by free text query. I'm kind of used now to all the keystrokes. It makes navigation very easy, but if you begin, everything I do actually can be done through the menu. Okay, let's do it. So let's find zestril. and here we find a tablet. So now we have zestril tablet, and I can hit T again to get into the table view, and I can go back again to the graph view. One thing you can find in the pharmacy is Advil, and then you see that it's actually the same as ibuprofen. And another way that I haven't shown you yet to look at things in this graph view is actually to hit I, and then here you see all the outgoing and incoming links. So on the left hand side you have the outgoing links from a node, and on the right hand side you have the incoming nodes for nodes. So I can select them. Okay, and so I could hit F, and I find that for ibuprofen there's already more than 300 links, so I can click on select, and I could actually select some things I was interested in, and then I get the graph view, which in some cases makes more sense. Let's go back one step. So we have ibuprofen. Actually, let's get rid of zestril. I got rid of everything. Okay, let's do Advil. Ibuprofen. And sometimes I'm going to do something where I want to find some links between two drugs. When I try to find these links, then the layout will change. So I hit the letter P, and now I kind of pinned ibuprofen to the background. And I can say, okay, also let's look at heroin. And here we have heroin. And let's also pin that to the background. And let's see, can I find any relationship between these two? I hit Shift F, and then I try to find the relationships. I find now that ibuprofen and heroin are both small molecules. It's taken by humans and other animals. It's an analgesic, it's a drug, it's solid, and actually it's referenced in both these two clinical trials. Now actually what you see when I hover over, say, heroin, then what you see at the bottom is the actual URL for this particular drug. Yeah, so it comes from the drug bank, and the number, that's kind of a standardized number, is DB and then 01452. But what Gruff does is whenever it sees something, it always will try to find if there's maybe a label for this thing, so that it's a lot easier to read what you have, because DB01452 isn't really that descriptive. Of course, this is something you can turn off, use label properties for the node labels, and now you see that things just have their formal names, but I don't want to live in that space, so I click this on again. Okay, so let's delete this. One thing that we have is an eraser tool where I can delete parts of the screen. So if I hit Ctrl-Shift-X, then I can start kind of erasing parts of my screen. One view that I haven't shown you is the query view. Now I can go here, and what you can see is you always can go to a graph view, a table view, and a query view. And so query view is W. Most of the time I just choose W, and I get into the query. And then I want to find a particular query that I've pre-cooked. And we also can do load query strings and save query strings. So if I hit load query string, then I have a bunch of queries. So let's start with this query. Here I guess most people in the audience can read Sparkle, so I'm not going too deep in detail. I'm not going to explain Sparkle, but basically we say find every drug side effect trial and title where there's a drug in the drug bank with the brand name Lipitor, and there is a side effect that has the label type 2 diabetes, and then find every trial that discusses this drug and that also discusses this side effect. And then if I find those, give me the brief title of the clinical trial and just show me the first 5. Yeah. So I do the query, and boom, I get 5 results. And so what you see, just like in a relational database, there's a result set with 4 columns. So there's a drug, the side effect, a trial name. And the title, what I can do is I can also show you to create the official graph from the results. So click on this. And what you see here, the same information you saw in the title, but now with the relationships between all of them. But what is really interesting is that from then on I can just keep going again. So I can say, well, get me the verification date, and I find the verification date for this trial. Let's do another Sparkle query. So here you say find the clinical trials, drug side effects and genes, where Alitora mentions drug and side effect and a gene, and give me the first 50. And now I find 50 combinations of a clinical trial, a drug, a side effect, and a gene. Again, this is much better on the screen. And you see that these trials have these infections, well, these side effects. By the way, if I click here on the side, so what you see here on the left-hand side is the names of the attributes, and if I click on them, you see them activated on the screen. And the other thing that Graph does is for every node that you see on the screen, it will always try to find also the class of the thing. So that also makes it much more readable, because instead of just colors, you will find all the types too, and you can look at all the genes, and you will find the genes in this database. I can find these relationships, of course, also completely automatic. So say just for fun, I wanted to find a relationship between this trial and this trial. Well, I go to I again, so to see the things that I want to explore. Well, I can explore everything. And I could say, so how is this thing related to this thing? And I will probably find, some relationships. We'll find relationship to trials. They both require that you're 18 years. That's interventional. The point I wanted to make, you can go and find automatically relationships between clinical trials. The next thing I wanted to show is I do queries. So what sometimes happens is you have one particular clinical trial, and you want to say, give me all the clinical trials that are very close to this one. Or you find a particular drug, and you say, okay, find me all the other drugs that have the closest description to this particular drug. Well, it's really hard to express that directly into a query language like Sparkle. And so I wrote some additional code. We'll look at a set of predicates, and we'll find all the other, in this case, clinical trials that have the most predicates in common. I shouldn't do this with words. Let me just show you. So say find close clinical trials. So here I say this is prologue. Select every clinical trial and frequency and title. And then the first thing here is a prologue clause. So I say give me all the articles that are close to this particular clinical trial. And then look at the diseases, the side effects, the drugs, and the targets. Give me the first 5 results. And then give me the names of the clinical trials and the frequency for this particular clinical trial. And then when I find these clinical trials, find the brief titles. So I evaluate, and so I get 5 articles that are closely together. It has got 19 the same items with itself, obviously, so there's 19 values for these 4 predicates. And then the next one that is close together, so this was for wound installation, and this is for skin and soft tissue infection. So you kind of see it's the same thing, although the other ones, I don't know why they get so many links. But let's just look at them. So here are the 5 clinical trials, and say now you want to do a little bit more research to figure out why they are close to each other. And so what you do is you go to I, and let me deselect all the predicates, and then let me only look at, say, discusses diseases, drugs, side effects, and targets. Copy. Okay. And then again I say, okay, so this was the topic of the trial. Let's see, why was it close to this one? And then I find that these things have pain in common, vomiting, hypersensitivity, an AV block, a heart block, nausea, clotting, etc., etc. I can go a step back and say, okay, what is this thing in common actually with this one? And mostly the same actually. So this is a whole different way of doing queries, but again, it fits nicely into this this paradigm.